Hello everyone, my name is Sommer Panage, and I am the iOS lead at a small tech startup, fitness startup in San Francisco, California. Today I want to be talking to you about something that's very, very important and often neglected, and that is accessibility. So this is a lightning talk, so I'm going to move pretty quickly, so let's get started. So first of all, if you're new to accessibility, you might be wondering, what is it? Accessibility means using technology to overcome challenges. And those challenges can be various. There are visual challenges. Perhaps someone is blind. Perhaps they have partial vision or low vision. Perhaps they're colorblind and have difficulty differentiating between reds and greens. But maybe it's none of those things. Maybe you're just outside and the sunlight is really bright in your phone. Or perhaps you're driving and you can't take a look at your phone. Some other challenges exist as well beyond visual. There are motor challenges. Perhaps you have something like cerebral palsy or muscular dystrophy. But maybe you fell off your skateboard and broke your hand. Or perhaps, again, you're just driving your car and you can't touch the screen right now. More challenges exist beyond that even, auditory challenges. Some people are deaf or hard of hearing. Others may have only hearing in one ear and can only hear mono audio. But maybe you're just using your device in a very noisy area. Or perhaps you just have your audio turned off because you're at a conference and you don't want your phone talking to you. And finally, there are learning and cognitive challenges. Some people have autism spectrum disorders or dyslexia or severe ADHD. But other people just may be challenged by technology in other ways. For young children, technology can be very challenging, and it can also be hard for older adults. So, as you've noticed in these slides, not every challenge is a disability. It can simply be a challenge that you or I could face at any time. And that's the key thing, and if you get one thing from this talk, it's that accessibility is for everyone. When you make your app accessible, you make it easier for everyone to use your application. This comic, I think, illustrates the point very, very well. We see someone in a wheelchair asking for people to shovel the ramp into the school, and we see them saying, wait, we need to shovel the stairs first. And the person in the wheelchair points out that if we shovel the ramp, everyone can get into the school. And I think this is the key thing here, is that when we make something accessible, it generally benefits absolutely everybody. And that's a win. So when it comes to accessibility, I could speak for 2 hours or 3 or more. I won't, don't worry. But there are so many technologies that we could talk about. The one I would like to focus on today is the one that probably has the heaviest engineering lift, the one that you as a developer have to focus on the most, and that is VoiceOver. So what is VoiceOver? VoiceOver is a screen reader that is built into every iOS device, as well as your Mac. And this screen reader is used primarily by the blind and the visually impaired. As programmers, we need to support VoiceOver in our applications in order for them to be accessible. So rather than me talking about it, I want you to watch someone using VoiceOver so you can really see how it works. Okay, we got audio.
Well, I'm going to show you. So a lot of devices have this thing that you probably never even thought to use or check out. It's called accessibility. That'll show you all different sort of things. How to turn the speech on or off your phone to white on black and white, maybe mono audio. There's all sorts of different things to do. So I just use the VoiceOver one, and it works incredible. But it's a very cool thing that allows me to use something that has a touch screen, just like you do. So each thing, touch it once, it tells you what it is, twice to perform the action. And then to move to the different screens, 3 fingers to go left like this. So let me show you how some of this stuff works. So let's. Alright, so let's see what's going on in the Twitter universe today. Why did I tweet something? Alright, so when I tweet, I generally cheat and use Siri. It's easier that way. Happy Easter, comma, from the blind film critic.
Happy Easter from the blind film critic.
Seems pretty innocuous, nice little tweet. So let's put it up. One of the things I don't think people get is when they talk to Siri, if you have
Alright, so there's a quick demo of VoiceOver. As you can see, we have a cursor that moves around the screen. And instead of having to tap specific places on the screen, now the user can tap anywhere and it activates whatever's under that cursor. What's more, VoiceOver has special gestures, 2-finger gestures, and 3-finger gestures that allow ease of interaction with the system. So what do you need to do as a developer to allow someone like Tommy Edison to use your application? Well, first of all, you need to know what you need. So we need to talk about what it means to audit your application for accessibility. And then, of course, you need to write what you need. You need to know how to use Apple's APIs to access VoiceOver correctly. So let's start with the audit. In order to audit an application, we need to have an application. So this is a little app that I wrote for this talk. It's called Let's Learn, and it's a simple little app that for children to learn English and Chinese. We can see that they can learn numbers or colors or shapes. There's some buttons to tap, and there's a review section that goes through all the vocabulary alphabetically. And that's it. So this is the little application that we're going to be using to take our dive into accessibility, and we're going to kind of see where it starts off. So the first thing we need to do is we need to audit it. So what does auditing look like? Well, we need to turn on VoiceOver, we need to navigate through the app, and we need to look for a few key things. We need to look for anything that VoiceOver skips, anything that it doesn't talk about, because we want to make sure that our users can experience everything on our screen. And we also want to look for items that maybe don't get explained well, that don't tell the user what they do or who they are. So here we go, we're going to go into our settings and turn on VoiceOver.
VoiceOver on. Settings. App. Let's learn. Double tap. Learn numbers. Learn colors. Learn shapes. Review. Learn numbers. Learn numbers. Let's learn. Back button.
So far,
Learn numbers. Heading. How many circles are there? Union Jack. Button. China flag. Button. Next. Button. Next. China flag. China flag. Got it. Button. Got it. Learn numbers. Let's learn. Learn numbers. Rows 2 to 4 of review. Review. Head black.
黑移动
Blue.
蓝移动
Circle.
圆看
A.
看齐
I can't tell you if Siri's getting anything right, so. Anyway, so we just saw the audit. So let's talk about it. Let's see what did we learn. What were some issues that came up? Well, first of all, on the very front page, the screen reader spoke all of the correct things. It told us learn numbers, learn colors, but it didn't tell us that if we tap on those things, we go somewhere. And that's not always super obvious. So it could be better. We want to make sure that we indicate to the user that these are things they can tap on. Also, the answer buttons, they didn't really have the right names. They had the names of the images that we said Union Jack and China flag, but that doesn't really tell us what these buttons do. They lead us to the answers in English and Chinese. So that wasn't very good. And also, you'll notice that nothing happened in the white box. VoiceOver completely skipped it. It didn't even know it was there. So we definitely need to address that. There's no way a user can count circles if they can't hear the circles. Another issue is that it's not clear what this got it button does. Got it? Well, where does that take me? Obviously, we saw that it goes back to the lesson, but that's not obvious. And finally, we saw that in this review section, we indicate if something is a color, a number, or a shape by the color of the cell. But there's no indication of that to our VoiceOver user. There's no way for them to know which cell represents which type of thing. So those are some issues we're going to dive into, and we're going to see how to address them using the accessibility APIs. And that brings us to code. I'll be showing a lot of code on the screen, so if you'd like to follow along, here are a couple links to the repo. And of course, you can access this after the talk as well. The master branch is going to have the original app, and the A11Y branch is going to have the version that I've made accessible. So, leave those there for a second. All right. So let's start with our first problem. Our first problem was that the learn items did not indicate that these were things you could tap, but they're essentially buttons. So we need these items to tell us what they are. It's a what question. In order to answer the what question in UI accessibility, we use the concept of accessibility traits. Accessibility traits can be applied to any object, particularly views, and they indicate what the item is. In UIKit, all UI controls automatically have the correct traits applied, so you generally don't need to worry about adding any more traits. Because of this, you always want to make sure that if you are adding traits to something, you're using a bitwise OR to add that trait in, because we want to make sure we preserve what's already there, provided by UIKit, unless you're really certain you want to override a behavior. So what are some common what's or some common accessibility traits? Well, a button, that's a trait that basically says, hi, you can tap me. There's a header, which makes navigation easier because the user can navigate by headers. We can have a link that tells the user they might leave the app or jump around the app. An image, pretty obvious. And the adjustable trait. This is a trait that tells the user that if they swipe up and down on an item, it's going to change some level. Maybe a volume indicator is a great example of something that would be adjustable. So how does this apply to our cells? Well, on that front page, we just had learn colors, learn numbers, etc. Some very basic Swift cell code that you've probably all written. Nothing exciting here. This is what it looked like. So all I just need to add one line to say that these cells should behave kind of like buttons. So I'm going to go ahead and I'm going to add or in the accessibility trait button to each cell. Just one line of code. So now we look at the code.
Learn numbers.
Result.
Button. Learn colors. Button. Learn shapes. Button.
And that's it. So just by ORing in that trait, the VoiceOver system now can tell us that these items behave like buttons. And we can look at the code we see at the bottom. That's all we did. Added one line, we got our button behavior. So it starts off pretty simple. Let's move on to our next issue. We said that the answer buttons don't have the correct names. They were using the default behavior of an image, which is to use the resource name. So we need to provide labels for these buttons that tell our users what they do. That's a who question. Who are you? What do you do? So who is an accessibility label. This indicates the name of an item. And the name can sometimes explain what the item does as well. This is going to be automatically supplied for text, as we saw in our audit. And these names should be short and clear. One thing you want to make sure is that the names do not contain trait information. That should always be provided by the traits. So we don't want to name our button answer button because the button is provided by the trait, which we learned about before. So here's our button code. Again, some simple Swift you've all probably written. Here's the English button. We create a button, we return it. So now we want to give it a name. We're going to call it English answer, since it gives us the English answer to the question. So we add an accessibility label to the button. I'm also going to add something called an accessibility hint. Sometimes if you feel like the label doesn't provide enough information, you may want to describe it a little more. That information goes into the hint. It tells the user a bit more about what they think it does. In this case, we may or may not need a hint. It's not obvious, but the good news is hints are optional. Hints are read later. There's a pause, and then the hint is read. So the user can skip over the hint if they don't want to hear it, and they can even turn off hints completely at the system level. So you're never really hurting anyone by adding a hint to be more clear about what things do. So accessibility label, who am I, and the hint, a little more info about what I do.
English answer. Button. Shows the answer in English. Chinese answer. Button. Shows the answer in Chinese.
And there we go. That's the result. So again, a couple lines of code, and all of a sudden our application got much more accessible. And here's the after. Same 2 lines, put into context. Now let's get a little more complex, because oftentimes accessibility is just that easy, but sometimes there's a bit more work involved. So as you saw before, in our white box, that's where we draw things for the user to answer questions about. And VoiceOver completely ignored the white box. So we need to provide information about what's in there. The first question is, why did VoiceOver ignore it? Well, that's because I'm drawing everything in that box using core graphics. VoiceOver only automatically is going to work with things derived from a UI view. Core graphics, not so much. So what I need to do is I need to provide accessibility elements that represent anything on the screen that I want VoiceOver to pick up. So that's what I need to do on this screen. We need custom accessibility elements. To create custom accessibility elements, we simply put them inside of a container view. And then for each object we want VoiceOver to see, we create the element. The container view must do two things. It must say that it itself is not an accessibility element, and that tells the system to look inside. Then it needs to set the accessibility elements array on itself, and that's going to then provide these elements up to the VoiceOver system. The elements themselves, each one must have two things as well. They have to have an accessibility label, and they have to provide some type of frame, and there's three ways to provide that frame. I can provide an accessibility frame in screen coordinates. I can provide an accessibility frame in container space, which is new as of iOS 10, and that frame is provided in standard frame coordinates relative to your parent view. And finally, I can provide an accessibility path if I'm not wanting to provide a rectangle. This is really useful for something like a map. So let's look at our code. So in my code, in order to have these lessons, I had a lesson protocol. It had an English string, a Chinese string, and it had a draw function that every lesson had to provide. It had to tell the system how to draw it. And that's how it worked originally. So here's some boring core graphics code that drew one of my rectangles. Nothing to see here. This is just some standard drawing code. So in order to make this drawing code provide accessibility elements, I need to create them. So here we see I'm creating a UI accessibility element with a container that is simply its parent view. I can set the frame, add a label, and then I assign accessibility elements to the parent view. And that's it. That's going to be enough information for the accessibility system to pick up those elements. So let's see what this looks like.
What color is the box? Box. The color of the sky and ocean.
And that's it. So with that little bit of code providing an element, now that core graphics drawing is surfaced to the accessibility system. So now that means I had to update my protocol to draw something accessibly. It now draws whatever it needs to draw and returns that array of accessibility elements so that the view that uses this protocol is going to be able to actually provide those. So here we can see the function. And we can see it in the lesson view itself. So in the lesson view itself, we override draw just like you do when you're using core graphics. We call into our draw accessibly function, and that's it. So adding a custom accessibility element or sets of custom accessibility elements is actually quite simple. It's simply creating the elements, assigning the frames and labels, and providing the array up to your view. So again, nothing scary and complex. Let's move on to our next challenge. As we saw before, we have that got it button. And if you're a sighted user, the got it button is really obvious. Oh, I got it. Tap, and we go back. But it's not necessarily obvious if I can't see it. Now, one thing I could do is I could add a hint. We learned about accessibility hints already, and that's a completely valid option, but we can actually do better. We can support a default back gesture. As we saw before with Tommy Edison when he was using his iPhone, there are some custom gestures that VoiceOver supports. One of those custom gestures is a scrolling one, which we saw, 3-finger scroll. We saw magic tap, which is a 2-finger double tap. And finally, the escape gesture, which is 2 fingers making a Z shape. And that's the one that we want to support today. So let's take a closer look at the escape gesture. As I said, that's a 2-finger Z shape. And it's supported automatically by a UI navigation controller, which means if I'm pushing and popping onto my nav stack, automatically a VoiceOver user can use that gesture and get back. But for modals, I need to support this manually, and the way I do that is by overriding accessibility perform escape. So if we take a closer look, this is my answer view controller that shows the answer and the got it button. And all I did at the very bottom is I overrode accessibility perform escape. And when the Z action happens, this gets called. And I say, do the exact same thing you do if you tap the got it button. So it does the same thing, and it returns true to let the system know that I handled the gesture. And that's it. So again, we have a very simple couple lines of code to much improve our user's experience. Because now our VoiceOver user doesn't even need to find the got it button. They can just do the default behavior, 2-finger Z, and they're going to get back to the lesson. Let's see this in action.
English answer. English and blue. Got it.
So that's the old way.
Got it. Learn colors. Chinese answer. Chinese and
2 fingers, Z. And there we go. So adding that couple lines, we now supported our default back gesture, and again, our application experience has improved. Let's go to our final issue. And the last thing we talk about is that we use color in the application to differentiate the 3 learning categories that we're providing for our users. But that color information is lost if I can't see it. So in this view, I can scroll through and easily see, based on the cell color, what type of item I might be learning. It would be nice if our VoiceOver users could hear that same thing. If they could say, I'm only interested in colors, and they could just hear the colors go by. Luckily, as of iOS 10, there's a new API that lets us do this. This is the rotor. The rotor has existed in VoiceOver for a very long time, but up until recently, we had no power to actually harness it. It just did default behaviors. The rotor is primarily used for navigation. You can navigate by headings, by individual words, and even by letters if you want to know how something is spelled. And now with iOS 10, we get to add our own navigation. The rotor looks like this. It shows up on the screen when VoiceOver is on, and I use 2 fingers to twist it, just like I'm twisting a dial. So in our review list, what I would like is to be able to twist the rotor to say colors, shapes, or numbers, and then be able to only select those items as I go through my list. So this more closely is going to match the experience of the sighted user. So let's dive into the code and see how we do that. Now the rotor code is going to be the most complex, so I definitely recommend if you're interested in checking out the GitHub repo. So in order to set up the rotors in my init, I'm just going to call my setup rotors method. So that's what it looks like, but you can't see it all. So we're going to break it down. What do I need to do to set up rotors? Well, for each category, shapes, colors, numbers, I need to go through and create a rotor. And then I'm going to assign that to the accessibility custom rotors variable. Here we can see that all I do is I ask via predicate, I say, are we going forwards or backwards? Is the user swiping up or down in order to go through the items on the list? Once we know if we're going forwards or backwards, we can then get the next index of our items. So we have our backing info of all the items on our screen, we get the next index, and that's it. It's either going to go up or down. Once we have the next index, we can go through our list of items and say, do you match what the rotor is asking for? Are you a color, for example? And when we find the next item that matches, we're going to wrap it up in a UI accessibility custom rotor item result. It's a very long name. And we're going to send it back. And if for some reason we don't find that, if we get to the end of our list and there's nothing there, then we just return nil. Again, this code looks kind of nasty, but basically we're just taking 4 simple steps. We're determining if we're going forwards or backwards. We're figuring out where the accessibility indicator already is on the screen, so we know where to start. We're then searching through our items from the starting point, and then we're returning the correct item in an accessibility custom rotor item result if it exists, and if not, we're returning nil. Those 4 steps get us this custom rotor behavior. So now let's see it in action.
Black, blue, circle,
语言形
colors, shapes, language, shapes,
So shapes is one of our new ones.
oval,
We jump to
楕
oval,
円形
rectangle,
rectangle.
oval,
So you can
楕
see
円形
it skips over everything that's not a shape. So now we've allowed our non-sighted users to be able to use the same benefit of our color system for our sighted users. So in summary, what have we covered today? Well, we talked about how accessibility is helpful for everyone, whether they have a long-term or short-term challenge that they face, whether it's physical or visual or auditory or learning. We talked about how to audit our applications, how to turn on VoiceOver and go through the application and see what's right and what's wrong. We learned some basic accessibility, simple things you can do in one line, adding a label, adding a hint, etc. And we talked about some pretty advanced features of accessibility, like accessing the rotor, overriding custom gestures. Now, I wish I could talk to you longer about accessibility because there's so much more. But the good news is that when you support VoiceOver, you get some other accessibility improvements as well. Switch systems, which are used primarily by people with motor disabilities, are going to also be able to access your app much better if you've already supported VoiceOver. And Braille actually uses the exact same system as VoiceOver. So if a user is using a Braille display, that's going to take whatever is the readout and instead put it into Braille. So you'll get that support for free. There's other things to think about as well, things like captioning, accessible design, and much more. So if you're interested in any of those topics, please feel free to ask me questions later if you see me around. And that's everything. So thank you so much for your time.